So definitely EVs are indeed tomorrow's next big thing. And let's start out. So before we start, a little peek into the things I guess you all should be knowing already. So these days, issues like global warming, non-renewable energy pollution, and the likes are very much subject to debates and discussions. So the world has accepted that the clock is ticking and is collectively looking into what innovations and technologies can bring about a change in the state of things. Now, since we are the racing club, let's look at it from our point of view. Beyond doubt, the automotive industry has the power to create a huge positive impact on this revolution. By tapping into the unending potential of the EV domain, day by day, more and more companies are investing a lot of time, money, and effort into electrification of mobility. And so soon, we can expect that EVs will be as common or maybe more than the conventional CVs we see and ride every day. Definitely, engineers with skills in EV related concepts are in high demand, and this will be so for a long time ahead. Without further ado, we will explain in brief about some basic terms and concepts you should be knowing before we move on to the crux of the presentation. So what goes in and comes out? The answer to this very question will actually determine the topics that we as a team will work on and what our projects will be based around. So as you can see here in the slide, all the integral components of a combustion vehicle, be it engine or engine controller, fuel tank, petrol, or the separate battery, most of these integral components will be changed, and the drivetrain or the source by which the car is driven and power is supplied has been replaced entirely by a battery motor wiring system. So basically, apart from aerodynamics, suspension, steering, and chassis, most of our other subsystems we discussed back in the orientation, if you remember, will require a huge major revamp. Also, since most of these components are electric or electronic driven by current, they also have an additional scope of intelligence and communication within and beyond the vehicle. So now that you have a layman's idea about what electric vehicle is and how fundamentally it's different from our CV, let's move ahead and look at what we as a club plan to do in our coming days or maybe even years. So talking about our current status, right now our team is working on what could possibly be our last combustion vehicle. So actually, if you realize this current time period could be a historic point in the timeline of our whole club's journey. Soon we are going to make our complete transition to electric vehicles. So buckle up guys, this is your opportunity to join us and be a part of this club's legacy. Coming to EVs, the electric roadmap projects will be rolled out soon, and you will be given a chance to join us on a project of your choice and start working on it right from scratch. The projects will lead to team recruitment, and then we will commence our preparation for various upcoming competitions. So all the planning and decision making process right now in our EV domain is based on our experience and some feedback we received earlier. So I know though you think that we as a club are just starting out in the electric field, our club does have a short little experience in EV which goes a year back. This has given us great learnings and insights. And that was our team's participation in FSEV 2021. So this is a competition conducted by Formula Bharat, which is the Indian establishment of the worldwide Formula student competitions. So the teams have to submit documents, reports, presentations, and various other categories pertaining to various aspects of a powertrain in an electric vehicle. So the powertrain is the method by which the vehicle is driven. So we had to present our method of working, our thought process, our decisions involved, and how together they complement each other and give a well integrated, efficient powertrain. So this was the first time our team participated in an EV competition, but the work was a bit rushed and like we completed it within 2 months. So there were time constraints and also there were COVID difficulties, but we did manage to make our debut a formidable one. So this gave us a sense of confidence in our potential. Remember, we too were beginners back then. So if we could do this much and come up with a rank of 19, then together we all can do so much more. But don't get us wrong, by 19, we do not mean that we are well placed. We still have a very long way to go. And from what FSCV 2021 taught us, we have modified our vision, our plans, our subsystem structures, and our targets. Now I'll introduce you to them. Let's take a look at our vision for the upcoming months. to take a huge leap towards going all electric, to innovate and to implement sustainable practices, to focus on the ground laying work of skill development, technical decision making and analysis, to secure top positions in FSCV 2022 in the various categories, to initiate preparations targeting Formula Bharat Electric 2024 right from the time of FSCV 2022. So something to get you guys excited here. I guess you might have noticed by now, like how you have seen our club functioning right from the orientation. You people will be leading the batches coming after you in the 2024 competition season. So if you remember, the magnitude of perfection with which we will complete our work right now will determine how advanced your scope of work will be when you guys are going to lead your teams. So if you see, our target right now is 2024 and we're starting our work right now. So the better our preparation right now, the better will be your scope and extent of your work when you lead. So now let's start looking at the broad division of subsystems we have decided. The projects rolled out will be related to various important key elements of each of these subsystems. To start with our subsystems, let's look at AMS and power distribution. Over to Anshuman.
Yeah, hello. So thank you, Gautam. So hello guys, I'm Anshuman Hanswari, sophomore and junior engineer at IITG Racing. So let us start with AMS and power distribution subsystem. So basically, AMS and power distribution subsystem sees that each and every part of the car gets the operational power it needs. So in the previous slides, you already know that the most fundamental difference between an IC vehicle and EV vehicle is that unlike petroleum and diesel, EV relies on battery pack for power, which is definitely more eco-friendly. Battery managing is a very tedious work. To manage the battery pack, we have something known as BMS, the battery management system, which tells us the battery percentage, oversees charging, monitors each and every cell, and many more amazing things that you cannot even imagine. Now let us dig a little deeper into the battery pack, which after all powers everything in the EV. Yeah, can you hear me?
Yeah, you're audible. Go ahead.
Okay. So, like, is the slides visible to everyone?
The slides are at battery,
Yeah, it's
right?
visible.
Oh,
Yeah, you can
yes.
speak.
Okay, as you can see in the slides, so we have many battery types here. A battery pack is nothing but many series and parallel combination of cells. Now, choosing a cell can be really tricky. You have lead acid battery, nickel cadmium, lithium ion, and many more. I'm sure of it that you have heard many a times the lithium ion battery. It's very famous nowadays. From devices as small as your phone, which you are using right now, to huge automobiles, lithium ion is everyone's first choice. So you might be wondering, why is it so? This is because of its high life cycles, high specific energy, and a reducing cost over the years that has made the lithium ion currently at the top of it. Now we have three variations of it: the pouch, the prismatic, and the cylindrical cells that you can see in the image. So each and every type has its own specifications, has its own uses. So, but specifically for automobiles, cylindrical cells are preferred because pouch cells are generally soft, and prismatic cells are expensive and have less thermal efficiency. So you can see like in current automobiles like Tesla Model S, cylindrical cells battery pack are used. This battery pack can have capacity up to 100 kilowatt hour, which can give you a range of 400 miles or 600 kilometers in a single charge. So now let us see how this energy gets to other components. So here you can see a simplified form of power distribution. Power to motors, lights, displays, everything comes from the battery pack only. So in subsequent slides, my friend Arnav will talk more about induction motor. You must be wondering now that the battery is basically DC and the motor is three-phase AC. How can they be connected? The solution is very simple. So we have a three-phase inverter which converts DC power into three-phase AC for motors. Also, you know that there are many components like what we said, display and lights, which require a different volt, like almost 10 to 15 volts to operate. But the battery pack only delivers high volt, almost 350 to 450 volts. In that case, we have many DC-DC converters which convert the battery voltage to the required voltage for many components. So this was a basic explanation how power gets distributed in an EV. There are much more things to look upon when you work on an EV. Once you work on projects, you will get more exposure to actual details for what goes under this subsystem. So thank you for listening, and we can move to motors now. Arnav, you can take on.
Okay, thank you, Anshuman. So, hello guys. Let's talk about motors now. So, my name is Arnav, and I'm a junior engineer here at our Automobile Club. So, in the automotive industry, there are two motors that are widely used. One is the induction motor, and the other is the permanent magnet synchronous motor, or PMSM in short. So, let's briefly see how these motors work. Okay, so let's start with induction motor. So when you open up the motor, this is what you'll see. On the left side, you can see the stator or the stationary part of the motor. On the right hand side, you can see the rotor or the rotating part of the motor. So if you notice, in the stator, there are three wires, okay? And these three wires have different phases of current flowing through them, okay? They're also connected in star configuration. So when you do this, a very interesting phenomena takes place. So that phenomena is of the rotating magnetic fields. So in this animation, you can see how the magnetic field rotates. Okay. So they have shown the field at three different instances. So one interesting thing to note is that the magnitude of the field doesn't change. Okay. So now let's see what happens at the rotor. Okay. So the rotor is just a cage made up of conducting rods. Okay. And when the field rotates, there's a current induced in the rotor bars. Okay, so is everyone able to hear me? I got a connection error, I guess.
No, yeah, we
No, no,
can
no.
hear
Yeah,
you.
yeah, you're audible.
Okay, okay. So now, why does this happen? Can anyone guess? Like, you can explain this with a law. So why does the rotor move in the direction of the magnetic field? You can write in the chats. Something that you have learned in 12th standard. Okay. So no one is saying. Okay, so basically it's because of the Lenz's law. Okay. So PMSM motor, it has a very similar construction. Only difference is that at the rotors you have permanent magnets. Okay, so what happens is instead of Lenz's law, you rely on magnetic attraction. Okay, and also in this configuration you can do many interesting things. Okay, so when you join the motor team, we'll discuss more about this. Okay, so before we move on, so I'd like to tell a small story about Nikola Tesla. So Tesla is the guy who invented the induction motor. Okay, and you'll hear his name connected to only Elon Musk and the infamous current wars. Okay, but you know, Tesla has done a lot, much more. Okay, so as a kid, okay, so a lot of hearts. So as a kid, Tesla Tesla could see very clear images. Okay, he could imagine almost everything. So so he was not able to control it in the beginning. So as he grew older, he was able to control those thoughts, and he started using these thoughts for his innovation. Okay, so Tesla claimed that he could assemble any machine in his mind first, then he would run tests on it. Okay, and if those tests were what do you say? Those tests were viable, he would make those in real life. Okay, he would make those machines in real life, and almost always the simulation results, the simulation mind simulated results always match the real life results. So that, how cool is that? Okay, so that's all from my side. Let's move on to let's switch over to the page.
Okay, so hello everyone. My name is Ritesh. So coming to the supervisory control systems, I will give you a funny yet analogous example. Okay, so suppose if the motor subsystem is your circulatory system and the battery subsystem is your nutrition system, then the nervous system would be supervisory control systems. In brief, it does the job of data acquisition, interpretation, communication, and intelligence. Next slide, please. Okay, so as you can see on this slide, the data about some important parameters and properties in a vehicle is being displayed. So I know it says fuel here, but I hope you get the point. Okay, so now while driving, it may not be possible to view all these values, but we know that most of these control variables have some critical values, that is a certain tipping value beyond which driving the vehicle becomes dangerous. Everyone knows that. Okay, so some of this might be changing fast and their effects might be changing even faster, so we need to be accountable for it. Moreover, if you want to see something like this, obviously you need some devices to measure these values and transfer these to a measurable form which can be read by the driver or the vehicle itself. So this is the relevance of supervisory control systems, where it measures, communicates, and takes decisions as well as displays information to the driver as well. Yeah, and thus the possibilities are endless. You can measure almost everything and anything related to the vehicle, make the vehicle understand how to implement certain actions based on these measurements, communicate between these values to different subsystems and sensors, and also to the central controller. This picture shows certain possibilities of SCS in a vehicle, but yeah, there are possibility total possibilities are limitless. So that's it about supervisory control systems. On over to you, Amon.
Hey guys, I'm Amon, a sophomore and a junior engineer at IIT. So in safety subsystem, we mainly focus on problems that the EV might face, and then we have to come up with a solution of this. So you might know in ICVs, gasoline is used, which is inflammable. But in EVs, we use batteries. But we also have to keep in mind that even though batteries are not as prone to combustion as gasoline, they might still catch fire or even explode under an abnormal condition. So that is why we must have a proper battery management system or a BMS. We also include various other safety features. For example, BSPD, which is a brake system possibility device. It is a part of the shutdown system of the car, and it consists of a non-programmable circuit. This circuit prevents the driver from braking as well as accelerating at the same time. In all EV vehicles, a master control switch is required in the cockpit. It is used to shut down all the current supplies of the EV in case a fault is detected. IND, which is an insulation monitoring device, monitors the insulator's resistance of the high voltage electric vehicles, and it provides effective protection against the electric shock. So having a great safety system gives the driver a more assurance. Thus, it becomes very important. So we will go more deeply into the subsystems when we do various projects related to it. As these above explanations is just the tip of the iceberg. and much has yet to be explored. So with this, we end our brief intro of all our subsystems, and I hand it over to Manish.
So, thank you, Aman. Hello, guys. Myself, Manish Pamar, Junior Engineer at IITG Racing. So, now we are nearing the end of our pre-project presentation. Now that you know the why and the what, let's just answer the questions how and when. So, our answer is so form will be floated soon. We will first learn the basics together. Then we will divide everyone into project teams. And the timeline of the project will be based on the extent and scope of the topic chosen. And the teams will be consist of a mix of sophomores and freshers. Until there is any update on the campus situation, team are required to carry out their research and decision virtually. Move on next slide. So let us look at some of the tentative topics for the electric roadmap projects. Okay. So to start with, we have a project named Implementation of Electronics and Supervisory Controls. In supervisory control system, as explained earlier, are measurement systems that consist of a central host, one or more remote units, a communication network, and specialized software. In this project, we would be implementing the electronics and sensors required, taking input data from them, process it, and redistribute the procedure data to the other subsystem where that data is required, using a communication protocol like Canvas. Our next project is torque vectoring. So basically torque vectoring technology is a vehicle's ability to vary torque in each wheel. This technology is designed to improve steering response and handling while also improving vehicle dynamics. So our project is focused on evaluating different torque vectoring strategies. For example, you can use 2, 3, or 4 motors and supply different power of each motor. But this option can be expensive and maybe have to search for alternatives. After selecting the suitable strategy for our needs, we will implement the control algorithm on MATLAB and Simulink. As you know, MATLAB and Simulink already. Our next project is model-based design for BMS and motor controller. So, as my friend Ansuman has already explained, BMS is designed to monitor and parameters associated with the battery pack and its individual cells. It is also collects data to eliminate battery pack and eliminate safety risks and optimize the battery performance. In our project, we will make a model of this on Simulink so that we are able to test the battery performance in different circumstances. We will do the same for motor controller. Our next project is regenerative braking system. So regenerative braking is a unique technique that is used in electric vehicles to capture energy. Braking in disc or drum is usually caused by friction. The energy was conventionally wasted into surroundings by the means of heat and sound. So to reduce this loss, nowadays electric vehicles use regen braking, which uses force due to back EMF to reduce the vehicle speed. The motor is changed to generator mode and a part of energy, 20 to 30%, can be again sent to battery. The disc brakes and regen brakes both are used in car to facilitate quick stopping. And in this project, we will research on the details of this regen system, try to increase its efficiency, and will make a model which can work with motor controller and BMS to capture energy back to battery pack. So our final project is charging infrastructure. The project will involve in analysis. Can you see which slide is open?
Yeah, we can see. Go ahead.
Hello.
Yeah.
Okay. So in charging infrastructure, the project will involve an analysis of the charging infrastructure required in India to adopt electric vehicles on a large scale. In different technologies of charging that can be implemented the potential of battery swapping, role of public policy, and the strategies that must be applied to develop charging stations as a substitute for petrol pumps, and how locations of these stations are to be determined in a given area. So my portion is covered. Please continue, Gautam.
Okay, guys. So thank you for attending this presentation. Okay, so I'm assuming that some of you might have had the idea of some of these things from earlier, but I'm assuming that none of you know anything. And even if you don't know, there's no problem. We'll start everything from scratch. So if you are interested in one or more of these projects and you're excited to work on it, buckle up because we'll soon float the forms and you'll be asked to fill them and you'll be asked to fill out your preferences for what projects you like to work on. And even if you have no knowledge, you just have to have the interest and the sincerity for doing these projects, and we'll be guiding you throughout the whole process. We'll be starting working on this project from scratch. So yeah. Also, you have to note one thing that the 5 projects that we mentioned, these are not final and these are tentative, and they might change based on the amount of response that we receive from your side regarding how many people are interested in doing them. So yeah, I'm hoping that you all are also excited as we all are about what lies ahead. So we just need interest, sincerity, and passion from your side, and I can assure you that you will have a great time working with us, and you will also gain some good working experience from us, guys. So make sure that you track our mails on Outlook because we'll be sending the forms and necessary information related to these projects there only. And don't worry, even if you miss the email on the Outlook, we will ensure that these info reaches to your WhatsApp group, your branch WhatsApp groups as well. So yeah, stay safe and stay tuned. You can capture a screenshot of the page that I am presenting right now for taking the contact info. My name is Durgans. I am the secretary of Automobile Club. So you can drop a message on my WhatsApp if you have any query. You can also ask your queries right now. So I'll be giving you mic permissions. So if you have any questions, you can just either you can switch on your mic and ask, or you can drop it in the chat box. Wait a minute. Uh, I'll allow mic for everyone. So if you have questions, you first raise your hands and then go for asking the questions if you have any. Okay, so everyone can access the mic, I guess now. Hmm. Okay. So for doubts, okay. So we'll be forming. We have a Discord server, yes. So we might give you. We'll give you the link for that. Okay. Yeah, sure. We'll share the slides. Yeah. And we also recorded the meeting, so we'll be uploading the recording on our YouTube channel. So if you some of your friends might have missed the meeting, you can ask them to go through the recording of the session. We'll be forming a WhatsApp group. We'll soon roll out a form, and you give your WhatsApp number in it in that form, and we'll be forming a WhatsApp group. So we'll make you join a WhatsApp group, and all info will be shared on it. Wait, I'll just link. I'll give the link to. Give the link to our website, and you can find the links to YouTube channel and other contact details there only. Hmm. If you have any more questions, feel free to ask.
Yeah, this Sanu Saurav is asking, what exactly are we supposed to do?
Okay, Saurabh. So okay. So you have to. I'm assuming that you are a first year, right? Currently. So we are actually planning to work for Formula Student electric vehicle. We are planning to make a electric vehicle of our own to compete in the Formula Bharat. So what FSCV is? FSCV is a concept challenge. So what we do in FSCV is we conceptualize a powertrain and different aspects related to how we are going to design it. We don't actually design we don't physically design. We actually do just the simulation part, and we actually just conceptualize how the powertrain is going to look like and what things we will do if we are going to physically manufacture it. And that is what we do in FSCV. So our initial target is to work on some aspects related to torque vectoring or regen braking, the projects that Manish explained earlier. So we are going to work on those projects and we'll continue the work that we will be doing in those projects to FSCV. And further that FSCV work will be expanded to a physical model of a vehicle that will be showcased in Formula Bharat 24 Electrics. So Gautam is asking where will we get funding for the manufacturing? Okay, so the institute takes care of these things. So you did not worry about these things. I mean, no fund is going to be asked from your side. So you need not worry about that. We'll be sharing the slides so you can go through them. Just do quick Google searches for the terms mentioned if you have missed, or go through the recordings once. And if you want to ask anything related to the projects or anything else, you can drop a message on my WhatsApp number or Shardul or Akshita. So we'll be sharing the slides with you. Okay, the Discord server. Nikhil, can you please link the Discord server here? Saurav is asking, designing on computer is also involved. Yes, that is what we do in FSCV. We make models on MATLAB, Simulink, SolidWorks, and we perform some simulations on ANSYS and these software. So yeah, that's the only thing we do in FSCV. For Formula Bharat, we need to physically manufacture a vehicle. So we'll talk about that later. Does this have any prerequisites? Gautam is asking. So no, there's no prerequisite for this. We'll start and we'll teach you everything from scratch. We will teach you MATLAB. We'll give you we'll provide everything related to whatever you need to learn for this project. So we'll, even if you don't know a single word about electric vehicles, you can still work in this project. You just need to have the sincerity to work on it. You just need to do whatever we tell you to do, and I mean it will be fine. You don't need to have any prior knowledge. What exactly we as freshies will do in coming weeks, months? Like what will be our contribution initially? Okay, so initially you will be firstly we'll be acquainting you to certain softwares, like you might have heard of MATLAB and Simulink. So we'll be providing you courses. You will have to go through those courses and we'll be giving you some assignments related to that. We'll also be giving you NPTEL course related to electric vehicles, and you will have to go through that. So yeah, wait for the form to be floated, and once those forms are floated, we'll convey all this information to you on the WhatsApp groups once we form those. So yeah, don't miss out on the forms. Can you please share the list of subsystems? I think it was sent in the chat, but I can't. Acha, so Gautam has sent the list. Okay. If you have any other questions, if any of you, you can ask.
But yeah, we can share the form link here also, right?
What?
Form link यहाँ भेज देते हैं ना?
Wait. हाँ. Wait a minute. Okay, so we'll share the Discord server link soon. I mean, I think there's some problem and Nikhil is not available. So, we'll share the Discord server link soon. It will be given to you via mails and it will reach your WhatsApp groups. Don't worry. I'll give you link of the form. Wait a minute. Is there also a possibility that I'm not capable for this? It depends upon you. How well are you going to work for this? I mean, even if you don't know anything, you are in no way lesser than other people. I mean, you just have to follow whatever we tell you to do, and you can do this. Yeah, but it all depends on you. Can you send the form on Outlook rather than WhatsApp group? Yeah, we'll be sending the form on Outlook as well as the WhatsApp groups. कैंपस का क्या सीन है? अभी तो हमें भी नहीं पता कि कैंपस का क्या सीन है. देखते हैं. Is it okay if we choose our preferences after the basic courses? For the first year, right, that will be the standard procedure. We will be giving you the choice of subsystem once you have gone through all the courses, all the NPTEL course that we'll be giving, as well as the MATLAB and Civiling thing. So you'll have to choose your preferences after that only. And for the second year rights, we'll be asking them to fill the subsystem preferences right now, but you can change your subsystems or the project preferences after going through all the basic courses as well. So the project preferences are not final. Initially, you'll have to learn the basic things, and then we'll decide on the projects. WhatsApp group will be formed after forms are filled, right? Yeah. WhatsApp group will be formed. I guess the WhatsApp group will be formed in 2 or 3 days. So wait for it. Yeah, you'll be given material to learn. Campus was. I don't know. But we do not have any idea about these subsystems. So how can we think about it? So yeah, as I mentioned earlier, that you initially go through the basic courses that we are giving you, and then you will be asked to choose the subsystems or the project preferences. Can we fill more than one preference? So if you are a first year, right, you will not be asked to fill preferences right now. But yeah, you'll be asked to rank the preferences whenever we'll be asking those. Is there any WhatsApp group of IITG Racing? Please add me. There is a WhatsApp group for IITG Racing. Once you fill the form, you will be added to that WhatsApp group. Formula 1 कब चलाने मिलेगी? We actually make Formula student vehicles, so it's not Formula 1. It's slightly different from Formula 1. But once you are in campus and you are a part of the team, you can sure drive the vehicle. Yes, electric vehicle is a key player. But what if we don't know anything about these, but still want to join? You just fill the form. We'll make sure that you once you join the club, you know about these things. What are the benefits of doing this? I mean, it depends on your interest. If you have interest in doing this and you are inclined towards the core mechanical or whatever things we are working on, you can do these projects. I mean, they will look good on your CV anyway. Okay, so if you have any more questions, you can just unmute your mic and ask, or you can drop it in the chat box. So I'm stopping the recording now.